This presentation summarized the article Data-Driven Approach for Automatic Classification of Extreme Precipitation Events, Preliminary Results, by authors Gonzalez, Escobar, Chaglia, and Pelufo. The structure of the presentation is the following: introduction, materials and methods, results, and conclusions. The goal of this study is to classify and anticipate extreme precipitation events through hydroclimate features, use individual principal component analysis and regressional relief, as well as a cascade approach mixing both for feature selection, and evaluate the feature selection through a super vector machine-based classifier. This means that this study aims to choose the hydroclimate features that have the greatest impact in extreme precipitation events in the South America Andean region. Many works in weather-related projects have already taken advantage of a data-driven approach. Examples can be found in neural networks, machine learning, and even in modern deep learning algorithms. To better understand the data mining process, this article follows the CRISP-DM methodology. First, it is needed to capture and understand the most relevant information while being capable of creating optimum models that anticipate extreme precipitation events. Initial data is a set of multivariate time series collected from various sources. The collected data is known to contain sparse data and wide ranges of value. Furthermore, duplicate missing values and size homogeneity is also a problem. Then, data is processed by feature selection algorithms to form different training datasets. To model a kernel supervector machine algorithm is executed several times to conduct two and three class classification problems and measure the performance yielded by each dataset. In the evaluation step, the different methods of feature selections are evaluated by analyzing a box plot diagram of accuracy for each classification through each training dataset. As expected, variables that influence the most in precipitation events are established. As this article seeks to show preliminary results of an exploratory analysis of the dataset, this project underlies the baseline for future projects which might develop regression algorithms in neural networks, deep learning, or in general artificial intelligence related. Data used in this article is provided by Metropolitan Public Company of Potable Water and Sanitation of Quito. The obtained data is recorded with a frequency of 5 minutes. Two stations are used, station CO2 and station CO4, ranging from late 2017 and mid 2020 respectively, to produce both high-quality data and valid results. Well-established pre-processing techniques are highly desirable. This means that duplicate samples are deleted, and inner joint among the feature vector is employed. To solve missing data, linear interpolation is applied. Data dispersion was handled by standardization. Due to the information volume and computational resources surrounding hydroclimatic data, this matter can be treated as a big data problem. Also, interpretation from hydroclimatic variables can become complex because of their sampling frequency and the pseudo-randomly nature. Therefore, several steps are used to harness the most from this information. The main idea of the feature relevance analysis is to create several extreme event matrices by identifying extreme precipitation events and assigning a label to extreme precipitation values. Then apply PCA and regresional relief and the combination of both of them to each extreme event matrix to select information only relevant to extreme precipitation events. Finally, use a super vector machine to compare what feature selection method yields better classification accuracy, that is, what feature selection method creates better training. To evaluate the selected feature resulting from the previous section, 2 and 3 class problems are considered and classified by the supervector machine, with a radial function basis kernel setting gamma equal to 100 and a regularization parameter c equal to 1. In the case of the 2-class problem, the label equals 0 is given to all extreme precipitation event data. Label 1 is assigned to random sample data, whereas in the 3-class problem, the label -1 is given to data previous to an extreme precipitation event. Label 0 is assigned to data acquired since the moment of the extreme precipitation event. Label 1 is analog to the 2-class problem. Let us analyze the most relevant features according to PCA and regressional relief by counting how many times they were selected after analyzing each extreme precipitation event. First, wind direction is discarded from the datasets due to its cardinal essence. Then, in both cases, temperature is the most relevant feature for both methods. But they strongly disagree in solar irradiance and wind speed. Relevance, as stated by PCA, ranks in top 3 temperature, relative humidity, and solar irradiance. Meanwhile, regressional reliefs rank in top 3 temperature, pressure, and wind speed. Besides using regressional relief and PCA, a new feature selection can be derived from applying both methods in a cascading approach. With respect to the classification, these are the resulting box plot diagrams of the accuracy achieved by the training dataset after executing 100 repetitions in each supervector machine. In both cases, box plot diagrams show that features selected by PCA proved to be the most relevant to extreme precipitation events. In the case of the 2-class supervector machine, the training dataset resulting from PCA might perform better in average than all of the others. In both supervector machines, accuracy can reach values between 80 and 90% when using full dataset, but it should be noted that values could go down as low as 70%. In general, mean accuracy for complete dataset and PCA dataset are almost the same. Consequently, the 2-class supervector machine showed that its classification task could be enhanced using features selected by means of standard PCA. Finally, the conclusions. The core of the analysis is the comparison of the result given by PCA and regressional relief and the combination of both of them. The study demonstrates the quality of each feature selection method by undertaking a classification problem through a 2-class supervector machine and a 3-class supervector machine. Furthermore, based on experimental results, it can be stated that hydroclimate features in the South America Andean region are better selected by the data dispersion based approach. Thanks.